the channels. Should I just tell
It's spamming
I told
time.
my friends to go watch, but I was just like, should I just tell
It's spamming
I
time.
told my friends to go. Let's see, it's like twitch.tv. Adam 0, right? Then.
Yeah. Adam Jimenez 0. Hopefully you will be able to solve the problem efficiently.
Okay, I'll see. I'll try.
This meta solves the
Please.
problem efficiently, man. That's the only thing you need to say in an interview. Okay, I need to stop joking about it, man. It's beginning to be like bullying at some point.
No, I mean, it's okay. I think I'm a little bit. I've only been doing code forces contests lately. I haven't done leak code ones and binary search, but I'll see what happens.
Yeah, we'll see. We still have 2 minutes. Still nobody here. I'm gonna go spam in the big room that's going on binary search.
Yeah. Yeah. Oh, I totally got the link wrong. Okay.
You can chill for like a few minutes waiting for people.
Okay.
It's fine.
Cool. I actually told other people, like some other friends, to sign up for the interview thing. I was like, you know, I don't know, do the thing. So one of my friends from Google actually signed up. So
oh shit!
I think he put himself a 5 out of 5. So he might be like a ringer. Like he doesn't compete in the contest. You don't actually know his name on binary search, but like, yeah, he signed up.
That's good content though. But my only concern is like he shows up and solves the problem in 5 seconds, and I'm like, oh well, what do we do now? How did you get your job at Google? Can I have a referral, please?
Yeah, he might even be better than me. Like, do you know CCC, like Canada Computing Competition? Like, he did that stuff at a young age.
I've heard of it. Is it like UNACO but for
yeah,
for Canada, basically?
Yeah, for Canada.
USACO.
Yeah, because I don't know about you, but I didn't even do coding until university. Like, I didn't start at a young age. I know people like they tell me, oh yeah, I learned C++ at like when I was 10. I was like, when you're 10, you learned C++? I was like, I was playing like Call of Duty in like high school. I wasn't doing coding stuff, but
exactly. I'm just playing Minecraft. What are you guys doing?
Yeah.
Actually, I started like at 13, but with Game Maker, so it was like visual coding, I guess. So I was just making.
Oh yeah. I used like the Yo-Yo Games Game Maker thing.
Exactly. Yeah. That's pretty much how I got into it, but I was so casual. Like I think I touched C++ at some point, but like I noped out when like I ended up in the memory handling stuff. Like for a kid, I don't see how you can enjoy learning about like memory. It's such like a dry topic, I think. Like for a kid. So I just gave up at that point.
Yeah.
I guess I still do. Getting stuck with Python, man. Life is so beautiful when you do Python that you don't ever want to do anything else.
Yeah, I mean, I tell people, why make your life, why make interviews harder than they really need to be? Like, with Python, you just make everything so streamlined, so simple. But I know people that do it in C++. I know people that do it in Go. I know people that do it in JavaScript. So it's interesting, I guess, in their choice of language.
Yeah. Okay. The viewers are starting to be impatient now, so we're gonna get.
Okay, I'm not even seeing the chat, so
it's fine. They're just like, when are we starting? So I guess we're starting now. This is the time of our lives. All right. So the question of today will be: drum rolls. Oh boy, there's so many examples. I think I'll just take like 2. Okay. So let's erase this. And here we go. So the problem. All right. Is Labyrinthian Possibilities. So you are given an n by m matrix of zeros and ones, and starting from the top left corner, how many ways are there to reach the bottom right corner? So you want to mod the result by this big number. So you can only move right and down, and 0 represents an empty space, while 1 represents a wall you cannot walk through. For example, given the following matrix, return 2, as there are only 2 ways to get to the bottom. So you start from here, you can go right, down, right, or you go down, right. So the top left corner and bottom right corner will always be 0. So the constraints, both n and m will be less or equal to 100, where n and m are the number of rows and columns in the matrix. And here you have a few sample test cases that you can use if you want to test your solution. And yeah, that's about it. So basically we can do it this way. So basically you could start implementing like a simpler version of this problem, like starting without the obstacles, so without the ones, just trying to find the number of ways to reach the bottom right corner, like with a given grid of just zeros. And then when that version is working, we can move on to the harder version.
Yeah,
so
that makes sense.
Good luck and have fun.
Okay, thanks. Okay, so I think the first thing when I see this question is I'll probably try to clarify. Actually, it's kind of meta that I'm explaining what I would do, but yeah. So I'd probably like look for clarification stuff. It's fairly clear cut. If let's even just write out a comment. Let's just say looking at only zeros, so forgetting about the ones. So no ones initially. So n by m matrix, zeros, start at the top left and go to the bottom right. And then I guess also the mod thing. So let's write down, also remember about the mod. 7. So you can only move right and down, important. And then also zeros empty space, and given the example matrix there. So we return 2 of them, some of them blocked. Yeah. I mean, in terms of like clarification questions, when I first think about this, it's fairly clear cut. They're just all zeros, at least initially for the simplified version.
Yeah.
I mean, in terms of input, could we be given like no matrix at all?
Yeah, you could be given an empty matrix.
Okay. So probably just need to check matrix exists as well. Okay. And you can see the comments that I'm typed at the bottom, right?
Yeah.
Okay. So these are kind of, I guess, important things that we're looking at right now. And then I'm only going to touch on the brute force very briefly, but I guess if we had all zeros in here and we actually wanted to enumerate all the possibilities in the slowest fashion, but we'd get there in a correct way, we'd start at the top, and then basically as soon as we reach the bottom, we can add 1 to the counter, and then at every single point we either go down or right at each thing, and then that'd be kind of like the slowest way to count how many ways there are. So if let's copy this, make it over, then do it like that, and then let's place things up. So, or yeah, let's say we make it simpler. Simple test. Yeah. So if it's something like easy, like a 2x2, and doing it the brute force way, we actually have to enumerate through from the top left over to the bottom, and we can notice that it just goes either to the right or goes down, and then in this case it is 2, I believe, right? Because you go right, you go down, and you go down, and you go right.
Mm-hmm.
And yeah, so I guess that's the brute force thing. I'm spending a little more. Actually, do you have follow-ups planned or no? I guess beyond this.
What's your
This is
question?
kind of like this is kind of a meta thing. Do you have follow-ups based on this? Because I probably wouldn't spend as much time on the brute force thing if
Yeah, don't stress it too much. Like the follow up will be adding the obstacles, and then we can try to like find if you have the most optimal solution in time and space.
okay, perfect. Yeah. So let's just so that's brute force thing, simple example. What we can notice is from a certain point, we can count up how many we've got, how many times, how many ways we can get to a certain position in the grid uh, using some past values. So specifically, if I highlight this last cell here, it can be reached by going at this cell and then going right, or this cell going downwards. So if we start at, copy this over actually. So in a more advanced solving technique, if we start at this cell here, and then we can get there by 1 because we start there. At this point, we have jumped over from that initial starting point. So there's also 1, and there's 1 here. But then once we reach this final state, we realize that we can be reached by going from the cell that's from the left or the cell that's above it. It's actually 2 ways. So we can notice that it's like being added in those 2 cases. And then specifically, we look at the DP recurrence. It's going to be something like DP actually J for 2D thing, I minus 1 and then J plus DP J. So the current cell from above and the 1 to the, because essentially that is encoded as we can take the one from the right and it's jumping from the right and jumping downwards, which is exactly the same movement we've said in line 6. And in this case, we're only looking at the zeros, and that looks like our DP state. So if we keep a similar 2D matrix that's similar to the n by m thing, and then I think the important thing is, so let's talk about our plan. So normally I'll talk about exactly kind of what the algorithm we're going to do is. The first thing is like check input has matrix, like I mentioned beforehand. So we need to check if the matrix exists as well. Create 2D DP, and then also initialize ones on the edges. So that was kind of like in our example here, where we know that amongst this top row and amongst this first column, it's always going to be 1 because you either always jump downwards or you always jump to the right, and you can't really go outside, get any values from outside the bounds. And then as well, so then at each step after that, we're going to do the DP recurrence here that we've outlined. Let's just move this down here. So I'll put that in. And then think of it like that. So the current cell is equal to the one above it and to the left, and then at the end return the DP at the last one, like that. So bottom right cell. So that looks like our plan for the algorithm that we want to code up. And this is initially just with only the zeros. So I'm gonna. So I think that's probably our plan. Does that algorithm sound good to code up?
That sounds pretty good. I think you're ready to do it. Yeah.
Okay. Yeah. Normally, I ask about that because during interviews, I think it's important to make sure that interviews on the same page. So like if they either say like it isn't good or if like whatever, then like at least you stop me at that stage as opposed to like me coding up for like the next 10 minutes and then you tell me later on, okay, like either you don't understand or it's not like optimal or whatever. But this is just like a basic thing.
Yeah, it's the right thing to do. That. You're doing great.
Yeah. Yeah. So let's do abilities, matrix. So I have the plan here. Essentially, it kind of just outlines what I want to do. So first thing we said, if matrix is not, then we're just going to return 0. Otherwise, so the next step is to create the 2D DP thing. Okay. Okay. Cannot edit editor in read-only mode.
Is there a problem?
It's probably my internet, actually. It says it's in read-only mode. Let me restart the page.
Okay.
Oh, okay, it didn't save like half the stuff I wrote, okay. So yeah, let's just copy over the stuff he said. So that's basically line 78. Then 79, you want to get the DP thing. Do we want to do it indexed by 1? So that way we have the value. Let's do it first. Good. So we're gonna create the 2D DP thing right now. Okay, I'm just gonna swap these. I like the other way around. Okay. Okay. So it should be all initialized to zeros, and we have to initialize ones on the edges. So like I mentioned, the top row and the first column. So we could just do top row is going to be m length. So it's going to be row that the first column is like this. Row okay, so then the next thing I said was we have some DP state, and then we want to return the last one at the end. I guess also I should put the mod result. Don't want to be like the other person that forgot that to mod the result in the answer that long time ago.
Yeah, don't worry too much about the mod.
Yeah, I think the mod's only there for like
because of the statement. I was too lazy to modify it, but
yeah. Okay. So I think we can traverse through this traditionally, as in just like going through each row, because we're only looking above and we're looking to the left. Didn't index it by 1. So yeah, I'm gonna have to check the bounds, I guess, but let's just write the double for loop. Initially, we can kind of just almost copy what I wrote here. Yeah. So that looks to the left, and that one looks to this one. Well, to the left, this one that's above. So if I did one, I believe since we did the checks here, that could work. Get I of that. And I is always greater than 1, and j is always greater than 1. And then we get the last one, that in return. So let me look at this. Okay, I'm gonna run this through the simple example using the REPL. Actually, I can use a REPL right off to manually check the thing.
What do you mean use the REPL? Like just run it?
Like run the thing, yeah, with it like a test just to see it.
Yeah.
Okay. And just that'll be a little quicker. I know in some whiteboarding things they'll force you to run through it manually because you don't have something, but yeah. And this one should be equal to 2. So let's see if this even compiles so it works. True. Okay. So that was the simple test case I copied over. Like that one.
Mm-hmm.
Let's try like a 3x3, and then I guess we could try something else after, because this is the only one without the ones. 1, 2, 3, 3. Okay.
Cool.
So it looks like it worked for these 2 simple things.
Yeah.
We added, yeah. I mean, this is the one for the 0 with only zeros. Does that look okay? So we can start doing the one with the ones.
Yeah, it looks perfect. You explained everything like almost to perfection. I like how you commented each section. I think everything is super clear, and like I liked how you did the pseudocode basically before and made sure everything was correct. So I think that's a plus for that part.
Okay. Yeah. Let's so yeah, there's a variation on it. I guess now it's like what happens if you have ones in it. So ones in the grid. And let's copy over that first example that we had. Let's see if we can like formulate the DP thing to be a little different. So this is the grid now instead of the one here. And if we let's start with even like a simple example. Let's say we had something like this. Okay. So we have a wall blocking that top right cell. And it's probably something similar because we want to formulate this 2D array DP stuff. But let's see what happens when we have this blocking thing here. So if we do it similar to how we had before, and let's draw through an example. So at that first step, we have all zeros and then we initialize them to ones. So we're going to kind of follow the same algorithm we had beforehand. And we can even just copy over the same thing plan. So we've got ones in the grid. Create DP, initialize ones. Okay, this is what it would look like after we initialize ones. But the issue here is that we realize that the wall is at this cell, and there's not actually one way. Well, I mean, there is one way to reach to that cell specifically.
Sorry, your audio is getting weird. Something happening to your mic?
Yeah, it's probably my internet.
Okay. It's better now.
I'll repeat that again. Yeah. So we've initialized the DP up until kind of the stage where we have the ones. And the issue here is that it's not going to be the same because we have this wall at this cell.
Mm-hmm.
So in reality, there is one way to reach this cell specifically, but we also have to realize that because there's a wall here, it's actually going to be blocking it. So we can't have that same path where it goes, starts here, goes to the right, and goes down. We're only going to count the one that goes down and goes to the right. So if we actually want to do it correctly, it's going to look like something like this. So for the simple example, we can just think through the actual path ourselves. We go beginning, and then we go down and we go to the right. So whenever there's a cell, whenever there's a wall at a certain cell, we actually want it to be 0. So we can't use it, and it's almost like it blocks it. And let's think. So that might add a little bit more complexity because we're going to notice that our DP recurrence had us encoding both the cell to the left and also the cell above us. But if it's a wall, we don't actually want to use that value. So let's see. So we have the DP recurrence here, and then we also want to check there's a 1. It's a wall. Don't use paths to that cell. essentially it's going to be blocked off. We can't do that. So I think check input matrix, check to array, initialize ones on the edges. And I think this should still be okay. The DP thing is going to look a little different because it's going to be like this, but we're just going to have to know like at this step. You want to check if it's a 1, that is a wall. Don't use that path to the cell. Otherwise, if it's a 0, then we do use it. So we'll encode that somewhere here. We still reach turn the DP bottom 1 and then mod the result. So it's going to be fairly same algorithm that we had in the initial part, but now that we have walls, we have to check if it is a wall, then we just actually don't use that previous DP state. So that's kind of the change to algorithm, but the plan is mostly the same. Does that sound good to put up?
Sounds good. I'm just maybe worried about like when you're like reaching the last cell basically. Like if you just check like if the top cell and the left cell has a wall, don't use it. If the last cell in the bottom right has a wall, how are you gonna check it?
Isn't it actually that's a good question, but I think guaranteed it said in line 18 the top left and the bottom right will always be 0, right?
Right.
I mean, I should have asked that. I mean, yeah, that's my fault. But yeah, I'll copy. Okay, I'm gonna actually just delete that line. So it's not guaranteed that the top left corner and the bottom right will always be 0. So then, if it is blocked off by walls, let's say something like this. So the actual number of paths is 0, right? Because if we think about it, it's going to be like this.
Mm-hmm. Yeah.
So it'll look to the above, it's a wall. Looks to the left, it's a wall. So it should correctly give 0. Is that yeah? Okay. So I think that's what we kind of want to encode it as. Yeah. So does that sound good to code up then?
Yeah, it's perfect.
Okay. Cool. It's good to get that clarified rather than finding out like 5-10 minutes down the road. Yeah, I'm gonna copy what I wrote already because I want to not write it all again. And the big thing is at the step on line 153. So we know we want to check if at a certain point it is in fact a wall or not. So okay, I'm torn. I'd probably multiply it by whatever the previous value is, like this. If I was doing it like contest or whatever, so that way it multiplies it by if it's a I should flip it right.
Yeah.
Yeah.
I see what you're doing. Yeah, you can do it like that if you feel like it.
But that's actually, I feel like that's like bad to do in an interview because it's like I'm doing like either like bit flipping stuff. So actually, what I'm gonna do is write more verbose stuff, but basically just be like, if this is 0, just gonna add this, and then do the exact same thing. That's it. So what that should basically be doing is just check not wall, starts out at 0, and then only adds it if it is not all wall. And then and then return the last thing. So let's test that out with the more complex thing and see how that works. We have that one. We have try that out. Let's just name this possibilities 2. Then reset it as bubbles. The correct value should be 2. Let's run that and see. And actually, let's comment out the other one so we don't get confused. Okay, so this one used possibilities 2, and it had the value 2, which is exactly what we wanted. And let's test out actually some of the edge cases. So weird cases like you mentioned, we're not guaranteed stuff. So just run through this quickly. So you're given nothing. And then also let's see what happens when you cut it off. So there's actually no path. It's like this one. Okay. So in both of these it should be 0. Okay. So this is incorrect.
Dun, 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 dun.
Both. Okay, so the first thing I'm going to check is probably what the DP thing looks like. Oh, I passed in the wrong input. Okay.
All right. Okay. I see it.
Might be important to pass in the right thing.
There you go.
Okay, yeah. So I was a little worried there. I was like, uh-oh. So yeah, that should return all 3 truths because that gives 0, 0, 0, 0, 1. Yeah, it's like that. And yeah, I mean that's probably the thing. If you ask me for like what's some good unit tests, because I've had places ask like what's good for like testing stuff, you could like check if there's only like one column. You check if there's like only one row. Then yeah, we check the empty case in M2. Just that out. M3. Do that, so it should both be. Okay, yeah. So that worked with the more complex obstacles case.
I think that's good enough testing, I'd say. Like, you don't really need to get like super in depth with like all the possible cases in the interview. You just have to like show that your algorithm is working with like some basic edge cases that do matter, but like I think that's good enough. Yeah. So now my question is, what's the time complexity and the space complexity?
Yeah. I guess yeah. I was gonna say for which one. I guess they're the same for both.
For the last one.
Yeah. So looking at space complexity, we use that 2D array. So we basically store the amount in each one. So that's m by n, and then everything else just edits that DP thing. The time complexity go through m times, and then m by n. So it's going to be the same thing as well. O m times n for time complexity and space complexity.
Yeah, correct. So can we do better? That is my question.
I think you can do better in terms of space complexity. Probably just like edit it in place, and then the time complexity. I don't think so because I think you need to, at least for the one with the obstacles, I think you need to visit each one. I think for the one without obstacles, you can probably do some factorial thing with like counting stuff because it's like predetermined based on size. But as soon as you add in obstacles, you have to like visit every cell.
Yeah, correct.
So yeah, let me think. So yeah, I mean yeah, you could just probably edit in place, add the ones, and then yeah, you basically check the value. Actually, let me write this down actually. Edit in place, and then it is a wall at in J 0. Otherwise, same recurrence, but with the matrix itself as the DB thing, as opposed to the actual extra space. Yeah, and then because walls are encoded as 0, we can just instantly add the values, which was something as an optimization I was thinking about. But yeah. So is that basically what you're looking for not using extra space?
Okay, so you want to, well, I'd say try ignoring the input. So don't change the input matrix and only consider the memory you use inside your function as the space complexity. So your DP table basically.
Yeah.
So do you see how you could
Yeah.
do it?
I mean, yeah. Technically, you only use what like the row above and the previous one you've calculated. So the ones to your left.
Mm-hmm.
So yeah, but I mean, I think it should work, right? If you just edit the matrix in place.
Yeah, you could do that, but let's say like the information in the matrix is important and used in another function, you wouldn't want
Oh,
to
yeah,
modify it, right?
yeah. Okay, because I was thinking like if you really wanted to optimize, you could do that. But I guess yeah, you only use the row above, and then the one to your left, which you could just store as like the previous value, so like previous to the left, and then for each, let me write this down actually. So you
Like
only use
it's pretty much a bonus question because like if somebody
yeah
came up with this solution in an interview, I think it would be fine. But just want to
yeah
see.
you only use the row above, and you use the row or use the value to the left. So just store those instead of having like a 2D thing. So in this case, it would be O of M space because you store the row.
Mm-hmm.
Yeah. Unless you're looking for something more optimized in terms of space than that.
No, I think that's the best you can. Yeah, it's the best you can do.
Okay, sorry, my internet cut out. Say that again.
I think it's the best you can do. O of M space.
Yeah. Okay, yeah, because you need like at each column the thing, and then also the one to the left.
Mm-hmm.
Yeah.
So want to try
Yeah.
it?
Yeah, I can cut that out. Okay, so let's do that. So we're still going to use DP thing, but now it's only going to be a row. And then we're also going to do the prev left, which is like the previous value to the left. And we're going to initialize that to 0.
So what's the prev left?
Because if we're adding the top value and the one to the left,
Mm-hmm.
we, well, I'm trying to see because, yeah, I'm trying to basically scrunch down the amount of space we need. So we know that we can get the one above it from that top row, and then the one at the left. Well, I guess the DP row is essentially okay. Yeah, we can just use the DP row that we're currently on. We don't need the previous left. Just look at the left one.
Yeah.
Yeah. So let's see. Top row is equal to ones. Okay. And then we go through the thing again. We're going to then have our DP thing. We don't use the information about I. Actually, let's clear this up a little more. I think so. We have a row. It's the row, and that's going to be simulating each ith row in the DP thing.
Mm-hmm.
We're going to want to initialize them to ones only if they are not a wall. Well, I guess we can do the same check that we had here, but we're essentially going to, okay, so dpj is equal to, still need that. Okay. We're gonna have secondary value because we need to store secondary information. But at this case, let's write this out clearly. dpj is going to be dp at I minus 1j, and then dp at j minus 1 is going to be dp j minus 1. So that helps us, I guess, formulate it similar to how we had it before.
Yeah, okay, I see.
And then base, and then, yeah, the amount is going to be equal to, actually, yeah, let's just do the same check we had with the zeros. Check if it's a wall. Yeah, we need to check if it's only one thing, one row. Actually, that will fail for the test one. Okay, I'm gonna pull this up first. Yeah, so j, this one's j minus 1. dp amount. So yeah, we have to, because we use dpj, we have to assign afterwards. I'm just thinking about the case where I have one row, like, and it splits it up in the middle. So then if it is,
I think it will be fine because you'll check, like, when you reach after the wall, you'll check if to the left it's a wall, then you add it, but since there's a wall, you won't add it. And
yeah,
since you start from I equals to 1, it will just be in the initial case. Yeah, okay, I see what you mean.
Yeah, because yeah, if we have like one row, then it's gonna think that it's a 1 even if it's a wall.
Yeah, okay, I see. Yeah, and you forgot to remove the 2 dimensions here.
Oh, yeah. So we start with the first one. And we want to encode it in the same way we always want if we haven't reached a 1.
Do you really need to set the whole top row as ones?
Yeah, I guess not. In this case, it's going to be just equal to it's going to be zeros, right? And then we do the first.
It's already zeros when you.
Yeah. So I think we can probably just delete this and then start it over here. And then for each one, yeah, so it'll be initialized to zeros. But yeah, the issue is that we still need to initialize it somehow based on the matrix value. I just do the inverse of the thing. It's actually no, it doesn't work because as soon as it's blocked, as soon as we reach the first one, we don't want to do that. So I'm just envisioning it like this.
Mm-hmm.
Yeah. So what we want is something like this. Do you know what I mean we could just like go through until we reach the first one?
Yeah, you could do that.
That's not like. I mean, yeah, I guess we could just do that then. J for a second. So yeah, we initialize until we see the first one, and then we'll do this DP step on that. Yes, let's see if that works out. I have some slight doubt. Give the same values. Oh. Okay, so it failed for a couple things. Let's see. So the first one and the last two. Okay. So I fixed the first and last one, and then it failed on this one, M4. So let's print out the EP actually. DB2. Oh, because it wrapped around. Right. So J has to be greater than 1. Okay, and that failed the first one again.
Well, I think since you're already initializing the first row.
Yeah.
Actually.
Yeah, because I skipped over it.
Okay.
Fails the first test, which is the complicated thing. Print out thing. Oh, I forgot we only get 1 row per time. Okay. Print out the first one as well. I never initialized it, that's why. Wait, no, never mind, that's it. Yeah. I thought I initialized it somewhere. It's not. Okay.
Seems good, yeah.
Yep.
Yeah, congrats, man. Yeah. I think like it's been 45 minutes-ish. I think that was like the time that was allowed.
Yeah, just in time.
Yeah, just in time, and seriously, you were like super great. I think one of the things I really enjoyed is like how you really like wrote down all your thought process and like explained it at the same time.
Yeah.
And you really like probe like what I was thinking. So basically you interviewed yourself in my place. So as an interviewer, that was really nice because I could just sit down and enjoy the show. So sorry about my dogs. I think one thing is like taking control of the interview, not waiting for like the interviewing to like start asking questions like, are you sure this is working? You can really have a conversation and like ask him like, is this the correct way like I should approach it? And like really like being communicative, I'd say, because that's really a good quality that people look in for an employee. So that's really something that impressed me, like the skill you showed to like communicate your ideas, and you like visualized everything. You show like what is the result that you wanted, and now you just wanted to figure out how you wanted to achieve that result. That's something I really liked. And all around just super great communication.
Thanks.
I wonder if if Twitch chat is as impressed as I am, because I'm wondering right now, how didn't you get some jobs in California, man?
I'll be honest, if you want to hear why.
Yeah, sure.
If you want to make me sweat during an interview, don't ask me algo stuff. You ask me system design stuff,
Oh yeah, that's
or like
scary.
you ask me to implementation things. Like yeah, basically because I've had a few places like they're like, go make a cron job schedule. They give you an hour. It's like that is like I guess much more open ended. It's a little scarier. Or like places that like to say like make chess. It's like
Okay,
it's
okay,
not
okay.
it's not as like predefined of like where to start. It's like like what is chess? Like is there movement? Is there pieces? It's like there's like so many more nuanced things, which is also why I've said I think interviews are going to move more towards system design stuff. Um, but yeah,
Hmm.
I think even in terms of algorithm stuff, I think there's always stuff I can improve upon, and even I've done a little bit of practice, either doing real ones or mock ones. So I think it's always good to share tips because one of the things that I at least learned was the reason why I write down so much stuff, and the reason why I try to at least include the interviewer into as much stuff as possible is because you're essentially writing the feedback later on, right? You're like strong hire, no hire type of thing, and
Hmm.
like really, I mean, how much are you gonna remember like 2 hours, like 2 days from now? A lot of times you're pretty much just gonna like copy paste whatever I wrote and kind of like look over that as notes. So if I write a lot of stuff and you've kind of seen like, okay, this is like his whole thought process here. There's a lot more stuff to basically like pull notes on as opposed to like if I didn't write as much stuff down. So that's just I guess one of the things that I've had to learn what to do. But yeah, that's basically small tips and stuff. So no, that this is fun. It's good.
Yeah,
Um,
I'm glad you liked it.
yeah, no, it's I mean, even though I'm helping other people do interviews, it's always good to do it yourself, get some more practice, and it's always I guess things to practice upon. So
Yeah.
yeah, yeah, no, this is good. I feel reinvigorated, and it's good to be under pressure sometimes. Because even though this wasn't like a high stakes thing,
Yeah,
it
it's
was
still
good to
stressful, yeah.
yeah
There's still
yeah.
like 17 viewers right now. Like it's almost like a whole class of people looking
Would you
at
say
your code.
70
Like
or
17, not 17.
17? Okay,
We're not there
17.
yet.
I was
We're
like,
not there
man,
yet.
we're blowing up. We're blowing up quick. Um, yeah, no, that's good. Yeah,
So
because
yeah,
yeah,
go ahead. Okay, I'll go. So one thing I'm curious is like when I ask you about like the space optimization, yeah, like you started struggling a little bit. And I think like
yeah,
your communication dropped up a little bit. Like since you were like
yeah,
thinking like a lot and trying to figure it out. Like I think you were like looking for your words a little bit more. So I'm
yeah,
wondering if there's some ways to like improve how to be like super confident even when you don't know what you're doing, like you don't know the answer. And I think if
yeah,
the answer to that is like trying to like communicate the more you can with the interviewer and trying to like get the most information out of him, because like if you're
mm,
talking with the interviewing, basically it's gaining you time to like think about the problem. I don't know if that
mm.
makes sense. I don't know what you think
Yeah. No,
actually.
that makes sense. Yeah, because I mean, yeah, because I didn't know. I mean, I would have felt that the O of m times n thing would have been suffice. But I was like, oh wait, there's like an optimization upon. I had to actually think. I'm like, do you need to go to all the cells? Like, do you need to like, what are we doing in like DP thing that we only need? Like, do we need to store everything? So yeah, I mean, basically that was me under pressure, actually making me think because I mean, I won't lie, I've probably seen this or like done this before.
Hmm.
I guess I haven't memorized it word for word, but like yeah, I have a general idea, so I wasn't as under pressure until like yeah, she threw me something new. Um,
Yeah,
so yeah, so yeah, there's that.
yeah, that's a good test to like if you already know everything, like there's no much test being done, like
Yeah,
if everything
yeah,
is known. Yeah.
yeah, yeah,
So I think one trick to like try to optimize some DP solutions like this is really look like at the dependency graph, I'd say. So like for each cell, like which cell does that cell depend on? So if we look at the recurrence relation that you wrote somewhere, like here, you see that basically
yeah,
the value at the current cell is based on like the previous row plus the column to the left. So
yeah,
basically we're just copying the previous value from the previous row. So instead of
yeah,
like creating a new row, adding the previous row and adding the column to the left, we can just reuse the same row because it's the same value that's being passed on to the second row.
yeah,
So if you see like
Yeah.
you're just reusing all the same information from the previous row, you can just reuse the same row and it's gonna give you the same result. So
Yeah.
like if you
Oh,
have
yeah, that
really
makes
like
sense.
some tight dependencies where you're only looking at the adjacent values, if like you're doing coin change where your values can be like, actually you can do for some version of coin change, but like if your dependencies are all over the place in your DP table, then you can't really like reduce the dimensions. But it's like
Yeah.
here, once we're done with the row, we're never using that data again, so we can get rid of that row and then we can reuse it, so we're fine.
Yeah.
I think that's
No,
the
yeah, that makes sense. That
yeah
makes
the
sense.
main strategy to like try to reduce the dimensions.
Yeah.
I don't
Yeah.
know if it's super clear for everybody.
Mm-hmm. Yeah.
And I think another point that is interesting, like it's basically a flex if you show this in an interview. If you get this question and you show it, it's basically what you actually mentioned it during the interview, the O of one solution when you have no obstacles. And that's basically based on the Pascal triangle. Because let's say I have it here actually. Like I took a grid here of just zeros and I printed the result for each cell. And if you look like each diagonal like this, it's doing a sideways Pascal triangle basically. So you have here a 1 and then the second diagonal is 1 1, then 1 2 1, 1 3 3 1. And if we look online at a Pascal triangle, it's like it's basically the same thing. Like you have
Yeah.
the 1 here, then the 1 1, 1 2 1, 1 3 3 1. So there's a O of 1 way to compute the value of any cell in the Pascal triangle. Yeah, calculating factorials isn't constant time though. You're right.
Yeah.
So what would be the complexity? Because I have the formula here.
Wait, you asked me about the factorial thing?
No,
Uh,
I'm just like pointing it out for like for academic purposes, I guess, or for
yeah.
fun. So basically, if you want to get basically the row of the Pascal triangle you're on, and that's basically the number of the diagonal you're on. So you can get that by just adding the row and the column and removing one from each one because they're one index at the start. So you can just add them together, and then to get the position in that row, you just put down the column like this. So the value for any cell in the first instance of the problem is just the number of combinations of x plus y where you select y like this. And if we look at we just finished the interview, Jeeves. There's gonna be another interview with Simon at 8 p.m. if you're interested. But if we look at the formula that's called the binomial coefficient, the underlying formula is actually some division of two factorials. Yeah, it's n factorial divided by k factorial n minus k factorial. And since a factorial is actually linear time, you have to do all the multiplications, then it's not actually O of 1. Right? Yeah. So is it, I think you get O of 1 space, but the time, is it the same?
Yeah.
It has to be. It's just a nice way to flex, I guess. So.
that's I mean, I don't think I would have known that normally. I just did like one of those, I don't know, those extracurricular math programs when you're younger, and they just had something similar to that. So that's what it made me think of.
Yeah, it's fine. I think it's better to stay like simple and humble and not trying to like flex too much during an interview.
Flex on the interviewer.
Yeah, it's like I'm so good, like I'm better than the interviewer. Like just give me the job already. Yeah, it's important to stay humble and focusing on like making sure everything is understood as best as possible, and really like Lawrence said, like empathize with the interviewer. Like you're basically in the same boat. If you like understand what the interviewer wants and try to like do his job in his place, it's really gonna simplify his life. And if he has a simple job to do, like he just has to sit there and like be impressed, then your odds of getting selected are really high.
Yeah, yeah. that's what kind of felt like. Yeah, sometimes you interview with the team itself. So if they like the way they communicate, if you like, if you see yourself working with this person in the future in the same way they've done the coding interview, it's like it's a good thing to do. So
Yeah.
yeah,
Wanna like shout out your new YouTube channel?
I'm gonna be honest. I don't think like I think it's still the hash. The channel is like still the hash. So I don't even know what it is.
Okay, okay,
I
okay.
think I think it's just to Google like reckless inkblot YouTube. Maybe put like Okta. Maybe put internship as well, and
Like,
like maybe it'll pop up in
let's
your
try. Let's try.
suggestions. But I think right now it's
Nope.
the YouTube algorithm probably still categorize it as spam because it has like 14 upvotes and no dislikes. So probably thinks, oh okay, this guy probably went to go get all his friends to upvote this thing and it's not a real video. So
Yeah.
until I get a dislike, then it's not like uh, a real organically found video. It's very forced. Yeah.
And
See, so
I'm not finding it. Yeah.
yeah, see, the algorithm hasn't. The algorithm hasn't. Maybe I'll just I'll post it in the. Where did I put the video? Let me get the link for a second. I'm hoping to make more videos. I was actually really inspired by your thing. I was like, man, I should go make some more videos. It's gonna be fun. I'm moving to the US, so it's gonna be a fun thing. Let me just pop it in the Twitch chat now that I have it open.
Yeah, seriously, it's a great experience. Just like talking to a camera and just explaining things. It really works on your communication, I'd say.
Yeah, no, for sure.
And I think, well, I can speak for myself. Like being introverted and like programming all the time, like you don't get to practice your communication all that much. So like having that kind of outlet is really a great thing. And I've heard some people that like when they tell their interviewers they have a YouTube channel, and like it's a big plus because I think it's almost like a stereotype that most like computer scientists aren't that great socially. So if you have that, it's like a bonus.
Yeah, no, for sure. And I mean, I don't know if you ever did this, but I did a ton of hackathons, especially in
I did
first
one.
and second year. Yeah, like there you have to like pitch your idea, you have to like talk to people. It's like that's where I basically learned how to like talk about tech stuff, at least. And yeah, so I don't know. I know hackathons get a bad rap sometimes, but I think if you're like starting out coding, if you're just like trying to meet people that are like working on projects and stuff, then like that's like I guess a decent enough way to do that. But yeah, I don't know if they're that big these days with COVID stuff.
I don't think so.
Yeah, no, because yeah, I mean, I was traveling around the U.S. and Canada for a little bit, literally just going to hackathons. They would like give us a free bus. They would like give us free food over the weekend. Like so, like you go to like Michigan, you go to like Princeton, you go to like Pennsylvania, like UPenn type of thing. Like yeah.
All I heard is free food, man. That's all I care about.
Free swag. They give you like free shirts and stuff, and all these companies come out. And,
actually, I'm wearing a hackathon T-shirt right now.
Yeah, there you go. So, yeah. My wardrobe's all hackathon shirts over me in real life. It's like I'm actually just sponsored. I'm just like running around with company shirts all the time.
Yeah.
So,
Legends say he hasn't bought any clothes since like he was 10 years old.
Yeah. So, yeah.
Yeah, Bunny's asking if I want to do a mock interview with you. Did you sign up?
I'm scared.
You're scared of what?
He's too good.
Yeah, I know. I'm scared too. Like, what question do I pick, man? I don't want to like have no content. Okay, you signed up. Basically, Lawrence is in charge of like scheduling everything. So right now, there's like Midnight Simon that's gonna be interviewed in 3 hours. I guess like I have nothing prepared, so maybe like in a couple of weeks. Yeah, I have. You guys want to show how many people signed up? Like it's crazy. I wasn't prepared for this.
No, I said yeah. Two of my friends all signed up. Bump up Grimmy in the priority queue. You should. There's a lot of people.
I have enough content for like 20 hours. There's like 22 people. Yeah, that's a lot of people. I'm gonna stop it.
22. Okay.
Flexing, yeah. BSIO plus Puggers partnership bug. Yeah, when do we release our Puggers merch, Lawrence? For the Poggers fan club. It's
Exactly.
it's not that expensive, to be honest. Like I checked on Teespring, they like charge a base price of like under $10 when you get a new logo. I guess you should do like a logo design contest. I would participate. I mean, even if I'm not a good designer, like that could be a fun community event. Like draw your worst logo possible, and maybe like by miracle somebody's actually talented. That could be fun. We can talk about it. There's the
Community call.
yeah, the
Yeah.
call Tuesday. That's gonna be hype.
Yeah.
Yeah. So I think we're gonna end this here. Like I didn't sleep at all tonight, so like I'm super burnt out. So maybe I'm gonna rest before the next interview. So it's been a pleasure, Jonathan. You've been great, and
Thanks.
I think I learned from you also, like just how you communicate, and you have like a certain style that I think like a certain natural charisma, I'd say. So I think you have good things in front of you.
Yeah.
Good.
Thanks.
Yeah.
Okay.
So good luck, man, and
Cool.
thank you for being here.
Thanks. Okay. See ya.
All right, peace, everybody. See ya soon. Bye bye.